Welcome. My name is Lamin Fofana. I am the site engineer for the Brikama water treatment plant. What you're seeing right now is one of the intervention boreholes. This is WB1, as you can see. And we have about 6 of these boreholes. And this is one of the boreholes that contributes significantly to the production of Brikama area that is already having impact on the people living in these areas. So we are very happy to have these boreholes, and we are very happy with the improvement that we are seeing so far. So thank you so much.
I'm Lamin Fadera. I'm the water engineer for the Germp project. Actually, the Germp project has come initially to intervene in electricity expansion and network reinforcement. But notwithstanding, we have small envelope that has come to at least support the water infrastructure, which is the intervention boreholes. We have 2 lots. We have 2 contracts, contract 1 and 2, and contract 1 comprised of 2 lots. The lot 1 is within the GBA, and this comprised of about 6 boreholes. These 6 boreholes are drilled within the Brikama area to support at least augment the production at Brikama water treatment plant. However, currently the system has been now commissioned to NAWEC and is now up and running. We have 5 boreholes that is pumping directly to Brikama water treatment plant of about 400 cubic an hour, about 400,000 liters. That is producing pumping to the Brikama water treatment plant. And in addition to that, we have another borehole that is WB5. That one is diverted or rather pumping to Kabafita elevated tank, and it gives you about 110,000 liters, 110 cubic an hour. Basically, the intervention boreholes, came in at the last part of the project, one can say, because, as I mentioned to you earlier, the Germp project was initially for electricity expansion. So because of the need is arise, and we've seen that, at least there is room to be able to accommodate some intervention, or rather to do some intervention project for water. That's why we come up with that. So for lot 2, actually the lot 2 is for provincial areas. That is our stand-alone system at our regional centers at provinces. So basically, for contract 2, we have 3 boreholes that we drill. In addition to that, we have construct 3 elevated tanks. In addition to that, we have 2 boreholes. And these 2 boreholes, the other borehole will be pumping to Brikama water treatment plant, which is already drilled but yet to be commissioned. And the other borehole is supposed to be pumping to other borehole will be pumping to Gunjur water treatment plant. Probably, as you may be aware, that Gunjur treatment plant is facing a serious challenges when it comes to water quality due to high content of manganese and iron. So for that being the case, initially one of the borehole within the Brikama well field has been diverted at least to support Gunjur, or to maintain continuous water supply system for Gunjur. When the 2 boreholes, that were decommissioned due to due to quality issues. So notwithstanding, the 2 boreholes that were drilled for contract 2, the other borehole will be dedicated for Gunjur, whilst the other one will be pumping to Brikama water treatment plant. Yeah, actually, this project has come up with a SCADA system, which eventually help for you to have at least a real time monitoring of the borehole or the system infrastructure. As you can see from the screen here, we were at WB1, and currently, if you see the flow, you are getting about 72 cubic an hour from that borehole. So what this SCADA system can do for you, basically, tries to tell you the real-time situation from all the boreholes that are connected to the system. So basically we have 6 boreholes and 5, as I indicate to you from my previous interview at the borehole site, that 5 is pumping to the Brikama water treatment plant. But as you can see right now, if we check the cumulative flow coming to the treatment plant, it's like 360 cubic an hour, meaning 360,000 liters an hour, excluding the WB2, which is currently not in operation. Because we've just visited there, you've seen we have small technical issue over there. But basically, if you check this one, as I indicated to you earlier, the WB5 is pumping to an independent system, a standalone system, where the borehole is pumping about 108 cubic an hour, 108,000 liters an hour. So basically, this borehole is not pumping to the treatment plant, as you can see from the schematic. That this borehole is not pumping to the treatment plant, it's pumping to Kabafita elevated tank. So notwithstanding the whole system, you can be able to see the pressure, the flow, even the current that is consumed by our system, by the pumps. So basically, and it can also be able to monitor your drawdown for you, at least to be able to analyze the water level at the borehole sites. So what this can tell you, in the incident that you have a significant drawdown from the boreholes, when the water level has dropped, even not at the site, you should be able to know it from the control room here. And also in the incident that, because as we are just experiencing it's a quite number of vandalism at our borehole site, but in the incident that maybe one of the boreholes from this system is being tampered or vandalized, obviously if the operators are monitoring the system, they should be able to tell, they should be able to know exactly there is incident and so borehole. And not even only maybe vandalism, but even if we have other issues, probably power cord, or maybe you have some technical faults around the borehole, you should be able to know exactly which borehole has this, or maybe is experiencing this fault. Not only that, the system too, is able to monitor your water level at the reservoir. As you can see currently, our reservoir, we are at around 1,280 meter cube. Currently that is the amount of water that is stored in the reservoir. So initially, for the existing system, yes, it was providing similar information for you, but because the system is no more functioning now, that's why when we come up with this project, we find it out that it is very important at least to get a similar system like this. But actually it's really telling us all the real-time situation, from the borehole sites up to the reservoirs. As you can just see, the flow, the cumulative flow coming here. And it's not limited to only that, but even if you have to generate a report, this can be able to provide you cumulative water flow, or water that has been abstracted from the boreholes pumped to the treatment plant. You should be able to independently, for each borehole, you should be able to abstract this information from the system. So at least for data security, at least the system can be able to give you that, and you can remotely control the boreholes. When you are even in the operation room, you don't need to go to the borehole side, even when there is power cut or so, to go and physically start these units. But in the other sense, you can do all kind of operations within the control room here. You can switch off a borehole, you can switch it on, you can monitor your voltage. If you have volt drop, you get all those signals, all that information from the SCADA system. So I think it's really gonna serve good.
This is one of the biggest treatment plants so far with NAWEC. It's one of the Brikama water treatment plants. You can see, as the engineer explained, Mr. Pereira, here we are at Balas. We are looking at the behind me is the aeration. All those boreholes that you have been seeing, their water is flowing into here for treatment and send back to the communities for consumption. So this is again NAWEC at work.